What's up, guys? My name is Cornelius Robinson. Today I'm going through all 72 working layout rules in Flux. So let's get into it. To add a layout rule, just go to the PCB tab, select an object, and edit the object-specific rules. Now, in order to get through all of these in a reasonable time, this won't be an in-depth tutorial, rather a brief explanation of each one. Also, keep in mind Flux is still in beta and some of the rules you'll find in the list are not yet working correctly, so I'm only covering what works today. Okay, let's start at the top with enabled. By setting it to false, the selected object won't be visible on the PCB. This can be useful for objects present on the schematic, but are not necessary for the PCB layout. Rotation unit sets the default unit of measurement to degrees, radians, or gradians. It's more effective if you apply it to the layout object. Grid spacing changes the background grid between centimeters and inches, and must be applied to the root. This can be done using a global rule set. Fill stitching density controls how close or how far apart the ground stitching vias are. Also, it must be applied to the ground net to take effect. Similarly, fill stitching offset shifts the placement of the vias by a given amount. This is useful if some of the vias are a little too close to a trace or a part, for example. The Z-axis is up layout rule is used specifically for 3D model assets and fixes a common error of it not being correctly oriented. The position rule is arguably one of the most used and controls the location of any object relative to the origin point on your PCB. You can enter up to 3 different numbers correlating to the X, Y, and Z axes. The position X, position Y, and position Z layout rules allow you to control each axis individually. Just like the position rule, the rotation layout rule controls an object's orientation in 2 or 3-dimensional space. Again, just like the single axis position rules, with rotation X, rotation Y, and rotation Z, you can specify the angle of an object in each axis individually. Size is pretty self-explanatory, but it's particularly useful for the board dimensions and component pads. While you can specify both axes in the size layout rule, being able to control just one axis at a time can be useful. When applied to a global rule set, the size minimum and maximums ensure that the future size changes remain within the tolerances you want. The scale layout rule is useful for changing the relative size of 3D models and silkscreen objects. Similar to the size rule, scale can be applied to specific axes in 3-dimensional space. When using ground copper fills, you can specify how close or how far away it is to the edge of your board. Corner radius controls how rounded the corners of a square or rectangular object are. It can be used for rounding the corners of a board or surface mount pads. Just like other layout rules, you can specify which corners are rounded and by how much. Pad shape, as you might have guessed, changes the shape of the pad between circular and square. This applies to both surface mount and through-hole pads. Pad type allows you to switch between surface mount and through-hole pads. It can also be used to create holes without pads. The solder paste mask expansion rule increases or decreases the relative size of the mask by a certain amount. This can be applied to individual pads or all of them within a project. Similarly, the solder mask expansion rule increases or decreases the relative size of the solder mask surrounding the footprint pads. Connected layers define which layers are electrically connected. This is commonly used to connect or disconnect copper ground fills on each layer. The hole size rule not only has some common sizes to choose from, but can also be used to create oval-shaped holes. Like other layout rules, using a minimum and maximum is useful to ensure the hole size never becomes too small or too big. Hole position is an interesting rule because it allows you to offset a hole. I'm not entirely sure what the use case is, but if you know, comment down below. Layout color is essentially the solder mask color. This is great for visualizing the final board that you build. Layout shape, unsurprisingly, changes the shape of the board. You can choose between rectangular, circular, or the flux logo. Silk colors refer to the color of the silkscreen elements, such as part outlines and reference designators. The asset rule is how you add a custom silkscreen, board shape, or 3D model. It's applied directly to the object being affected. When displaying 3D models, the default is to render physical materials for a more realistic model. You can turn this off, however, by using the physical materials rule. The Show Model Edges rule creates a thin black line around the model for better contrast. The Stackup rule is used to specify the number of layers your board has. It's applied to the layout object and supports up to 12 layers. As you might guess, the layer rule defines what layer an object belongs to. This is often used to move parts or traces to another layer. The content layout rule is a bit harder to explain, but it essentially allows text to change dynamically. For example, I commonly use the this.element.designator for the reference designator. The font size layout rule obviously applies to text as well. The default unit of measurement is in millimeters, but you can change it to whatever you want. When using text on a circuit board, it's important for it not to be too big or too small. Using font size minimum and maximum applied to text will ensure the text is readable when manufactured. Font style is applied to text and simply changes it to italic. Okay, I promise this is the last text-related one. Text alignment does what you think. A common use is keeping the reference designator always centered above the part. Not only can you apply the trace width layout rule to individual traces, but you can set it to a whole net or even the entire project. It really depends on how specific you want to get. PCB manufacturers often require minimum traces, so when you apply the trace width minimum rule to the whole project, you can be sure that the design is manufacturable. If you select any trace, you'll notice it already has the trace shape rule and is set to straight. Currently, there is no other option, but it seems as though this will change in the future. The preferred trace width rule makes it easier to cycle through common trace width values using a keyboard shortcut. You can even enter your own set of preferred trace widths. Stroke width changes the line thickness of silkscreen objects such as circles, rectangles, and lines. The stroke style layout rule changes a silkscreen object from solid to dashed. Again, this applies to circles, rectangles, and lines. When you have a dashed silkscreen object, you can control the length of the dash as well as the spacing between the dashes with the stroke length and stroke spacing layout rules. Shape start and end defines the starting position and ending position of a silkscreen line or rectangle in two-dimensional space relative to the origin point in your project. These layout rules essentially do the same thing as the shape start and shape end rule, but they allow you to define each axis individually. Alright guys, that's about it for this one. Leave a comment down below if you have any questions, and give this video a like if you found it helpful. Finally, make sure to subscribe for more content like this every week.